Assalamu alaikum. My name is Ibrahim and my groupmates are Hassan, Hussein and Yusuf. For the first module of the project Censor Yourself, you are just acquiring the raw data from the sensors which were of the no use. Now in this module, we are acquiring the data from the human body, a 15-year-old boy, and then manipulating the data in upper and lower limits to check whether he is having any disease or not. We have read more than 15 research papers and then come to a conclusion of the diseases, which I'll show you in the next part of the video in the software part. In this module, we have made two parts. For the first part, which is the making sense of your data part, we have drawn two sketches, one for the heart rate statistics and the second for SpO2 stats. In this case, we have set two limits, the upper and the lower limits. For example, for the heart rate of a person, if the beats are less than 60, then the person is having bradycardia. And if the beats exceeds 100 per minute, then he have tachycardia. And if the beats are in between the range of 60 to 100, then the heart rate is normal. We have acquired all this data on Excel sheet. Similarly, SpO2 level in the body is less than 95, then the patient is having severe hypoxemia. If SpO2 level is in between 90 to 95, and if the SpO2 level is in between 90 to 95, then he have normal hypoxemia. And if the SpO2 level is above 95, then the oxygen level in the body is normal. We have acquired all this data on DAC on Excel. On Excel, here's the time, date, heart rate and SpO2 level with the status that whether the heart rate and SpO2 are normal or not. You can see when the states are normal, it shows heart rate is normal and SpO2 rate is also normal. Now, if we do some exercise and check the statistics, the heart rate is normal, but the oxygen level in the body is decreasing, so it shows moderate hypoxemia. Now coming to the second part of the code, which is for the ECG. Here we have done averaging, and this sensor works on negative thermal coefficient, which is also called NTC. It takes 50 samples and then put them together in the formula, because the samples from the ECG sensor is in current and we have converted it into voltages and then into degrees Celsius. We have integrated all this and then made this one formula. Now uploading the code and then showing it in serial plotter. Now coming to the serial plotter of ECG graph. In the start, it is giving some raw data. This purple straight line shows normal human body temperature, which is 37 degrees Celsius. Now after some time it shows the proper data. Now the peaks shows P, which are peaks, and then there is S, which is dip, and then there is again peak, which is called Q. There are some abrupt peaks and dips, you can see. These are because of noise. Now let me show you values of celiac monitor. Here 33 degrees Celsius is the value of room temperature, and then the 125 is the value of ECG, which is being plotted in a serial plotter. This was all from the software side. Thank you.